Okay, so has the recording start? Okay, yes. Right, so today's lecture, we are going to look at longitudinal shear on the beam section relative to the textbook, chapter 6.6. Okay, so what are we learning down here? What are we trying to achieve down here? So we're going to analyze the strength. Okay, we are going to analyze the strength. This one is slightly different, yeah, of the joints. Elaborate over here of the joints in shear loading configuration. So the loading is still under shear. Okay, we're going to analyze the joint under shear loading. Okay, so now the joints, now we're going to look at the joints. Can either be glued. Okay, so you stick together, physically stick together in a glue. It can be bolted. It can be nailed. Okay, it can be screwed. It can be however you want to join it, but not welding. Okay, this is not welding analysis. I repeat again, this is not a welding analysis. So what are we talking about down here? Okay, so now if we have a beam, okay, we have a beam. So this is our transformation, and then we have a beam that looks like this. Okay, we have a beam. Okay, so a beam is simply supported, right? And let's say the beam has a certain load, okay, a certain load from a certain distance, or any type of loading. It can be a point loading P, it can be an omega Newton per meter soft loading, right? So let's say if these are made of wood, okay, or plastic or metal or artificial wood, okay, we want to know, and we are trying to avoid welding. Okay, imagine if you have a bridge, right? Welding the whole bridge will be, yeah, good luck. Okay, so let's say we want to put, we have two distance down here, and this distance over here are the spacing of the screws or bolts. Okay, what is this spacing? Right, so how many of you built a deck before? Anyone? How many of you have helped mommy, daddy build a deck, or your uncle or grandpa, grandma built a deck before? Anyone? No. So when you build a deck, you're going to put in nails, yes or no, or bolts. Okay, more or less nails or screws. What is this distance? Anyone? What is this distance? Any takers for that? What is this distance that you get? You will use your bolts or your nuts. What is this spacing? Right. So what I'm trying to do down here is we're going to calculate. Okay, what is this spacing? Okay, and it's based on shear. Right. Now, if we look at the cross section now, okay, we look at the cross section. Okay, we're going to look at the cross section view. So if we have a cross section now, so this is our Y and this is our Z. So for example, now we have a structure that looks like this now. Okay, now we have a structure that looks like this. This is a cross section, by the way. Okay, so we have a cross section that looks like this, and then we have a vertical piece coming down. right? Okay, then we can have also two small pieces going left and right. We can have two small pieces going left and right. So now the cross section of your structure is made of 4 separate parts. Okay, I repeat again, is made of 4 separate parts. Okay, so these parts. Okay, so these members. Okay, I'll call it member. So this is member number 1, member number 2, member number 3, and member number 4. And we don't have welding capabilities. Okay, so this is the cross section of our structure. So this is cross section. Okay, this is the cross section of our structure. Then we will ask ourselves, okay, over here I'm going to draw chain line. Okay, so the chain line over here represent how we are going to fasten the structure. Okay, so over here this is where we're going to put our bolt. Okay, we're going to put our bolt. Okay, or another way that we can join this together is we can also glue this. Okay, so over here, so let's say you don't want to bolt, you want to glue, fine. Okay, let's glue it. Okay, let's buy some Gorilla glue and glue it. So down here is glued. Okay, down here is glued. Down here is glued. Okay, so these are all glued. Okay, these are all glued. Now, question for you. Where will the structure fail? Anyone? Anyone? Where will the structure fail? Hello, Connor.
At the points where it's either been bolted or glued.
Yeah, it is the joint. Connor, well done. Okay, so failure, always remember this. Okay, failure will occur at the joints. Okay, failure. This is in real life, always the case, will occur okay, at the joints. Connor, can you tell me why you say that failure will always occur at the joint, Connor? Or anyone?
Because a joint of like a glue or a bolt is always going to be weaker than solid material.
Yeah, well done. Okay, or if you want some real life experience, I can give you a cheeky way of thinking about it. If you are confronted by someone, okay, that is twice your size or looks like a muscle man, okay, and you are going to be attacked by him or by her, right? And you are small, or like me, I'm old, okay. Where will you strike your first hit? Anyone? Were you hitting at the chest? No. Will you hit him at his stomach? No. He's going to have 6 packs. Where is your first point of impact? Anyone?
The genitals.
Sunshine, this has been recorded, man. You're killing me now. Now I have to go to that spot and delete it, okay? No. It's going to be at the joint, right? You're going to strike at the joint, okay? You're going to strike at the elbow. You're going to hit the person at the knee. You're going to hit at the hip, okay? The knees. The knees are usually the best place to hit someone, okay? So go for the joints. At the end of the day, it's all about techniques. So coming back to physics now, or to structural analysis, failures will always occur at the joint. Something simple for you to remember. Now, how are we going to analyze this? Okay, how are we going to analyze this? So, the calculating the stress or strength of the joint. Okay, we're going to calculate the stress or the strength of the joints. And the formula is simple. Okay, if I show you this, you're gonna tell me, Eugene, is that it? Okay, so we will have what we have is a shear flow. Okay, we're gonna use a lot on the shear flow. Okay, so the shear flow, as we know, is Q, right? It's a small q is equal to VQ over I, right? So this is one of the formulas that we are going to use. Okay, so this is one of the formula, and this formula is familiar, right? You have seen this before, right? In terms of shear flow, right? So over here, if we look at units, right? If we look at the units, so this is Newton. First moment of area is meter cube, divided by second moment of area, meter 4. So once you get rid of everything, the units over here is Newton per meter. Okay, so now we are going to relate the shear flow to the resistance force of each, I call it fastener. Okay, each fastener. So to relate this, okay, this is going to be a new formula. Okay, this is going to be a new formula where you have Q is equal to the force that the fastener could resist and then you're going to divide the whole thing by spacing. Okay, by spacing, we will spacing of the fastener. Okay, so this is the only new formula that you're going to that you are going to see. Okay, this is the only new formula, and then we're also going to apply. Okay, the other formula that we're going to apply is shear stress is equal to VQ over IT. Okay, that is the other formula that we're going to apply to calculate the shear stress of the structure. Okay, so that is the other formula that we're going to apply. So this is the only thing that's new. Okay, and you look at this, formula, the units will also be in newtons per meter. Okay, the newton per meter. Now, the question is, can anyone make a guess? How do we get this? The force that the fastener could resist. Anyone? How do we determine that? So I'll give you a scenario. Okay. So now we have a nail. Okay. So now we have a nail. I'm going to sketch a nail. Okay. I'm going to sketch a nail. Okay. So a nail. Okay. So this is a wood. Okay. Two pieces of wood. For example, holding it together. Now, how to determine the resistance force? Anyone?
Would it be the max stress times the cross-sectional area?
No, how do you determine it? How do you determine the resistance force? How? Right? So now in this is real world now, okay? You have a nail, okay? You have a nail, okay? How do you know how to determine the resistance force? Resistance force means what? Prevent the nail from pulling out. Anyone? Think simple, please. Anyone?
Are there standard tables
Standard tables.
that you can look it up?
Good answer. I don't know. Probably they will. But if now